Okay, so here is plan for today. In terms of time-wise, it should be pretty similar to yesterday. There's a couple of things that I want to go over. So teaching-wise, it'll take 20, 25 minutes somewhere in there. And then you should have 20, 25 minutes of work time today as well. Okay? I told you every day we're kind of adding one thing in. Yesterday it was the graphs, and I purposefully put two problems in your assignment to kind of spark questions a little bit. Number 2 and number 6 in particular, which we'll talk about both of them. 6 is going to be the one that I want to go over, because if you looked at the answer key at all, and we'll do that in a second, on number 6 there is a cross point. There is part of the graph that crosses a horizontal asymptote. That's what we're going to add in today, is the idea of how do you know when to look for a cross point, and then once you have that idea, then how do you find it? Okay, so those are the two things we're going to look at. Let me go to the answer key here real quickly and just kind of reference a couple things. So if you take a look on problem number 2, notice you've got a vertical asymptote here, vertical asymptote there, and a horizontal asymptote. But if you look at the actual graph, there is no cross point here, okay? There's no point of the graph that is crossing that horizontal asymptote, which is what is forcing this to kind of have the shape of a parabola. It's sandwiched, there's points here on the graph, but it's all sandwiched between all of the asymptotes, so it has nowhere else to go. It's very close to this asymptote, very close to that asymptote, and it doesn't cross the horizontal, so it kind of has to change direction, okay? So when you have two vertical asymptotes, that's the first thing that I want to mention. Whenever you have two vertical asymptotes, that's when you might have a cross point. That's when you need to look for, do I actually have a cross point? In this case, it turns out that you don't, and that's why the graph looks like what it looks like. Okay? That's why there's that parabola kind of in the middle. So that's what happens for that one. Then if you take a look at number 6 for a second, again, vertical asymptote, and if you notice on the graph, it does cross the horizontal asymptote. Okay? So this is the first one you've had that does actually cross. And in this case, in general, what I will tell you is whenever you do have a cross point, there's two things to be aware of. Number 1 is the general shape of the graph is going to kind of be that S-shaped curve. It will either kind of be a decreasing S like that, or it would go the other way and kind of be an increasing S. Okay? So it will look like that, one way or the other, and we'll talk about that in a second. The other thing is, if there's a cross point, it is usually between the two vertical asymptotes. Okay? So that's really where you're checking, is it's in the middle of the graph, not on the two ends. Okay? So with that being said, let's actually get into problem number 6 here. Let's actually take a look at this one, and we'll work our way through it. We'll use this kind of as a half homework question and a half first example of cross points. Okay? So here we go. Let's start right at the beginning as always. Horizontal asymptote. In this case, top heavy, bottom heavy, or tie. Tie, which means y equals what? -1/2. There you go. There's your horizontal asymptote. Now, if we keep going, in order to figure out holes, vertical asymptotes, all that kind of stuff, the next thing we need to do is factor and take a look at what those problem points are. So, let's factor this. If we factor the numerator, we get x minus 4 and x minus 2. And if we factor the denominator, it's a greatest common factor. Quick heads up as always, if you're pulling out a greatest common factor and the x squared term is negative, take the negative with it. Okay? That way the factor that's left behind will be x minus or x plus something, not a negative x. So let's take a negative 2x out of that, which will leave us with x minus 3 as our other factor. And right now, we should be able to identify what can x not equal. What are my discontinuities? 0 and 3, correct. Okay, 0 again is coming from the negative 2x. 3 is coming from the x minus 3. Okay? So two different values of x that you cannot have. And now we start organizing those. Is there a hole in the graph? No, why not? There's no factors that cancel. So in this case, there is no hole in the graph. I'm just going to put down none, which means both of those discontinuities are vertical asymptotes. You have two vertical asymptotes, one at x equals 0 and another one at x equals 3. And that right there, like I said, whenever you have two vertical asymptotes, that's kind of a signal. I'm going to need to check for a cross point in this problem. Okay? If you only have one, you don't really have to worry about it. But if you ever have two, that's when you need to go through and you'll have to check. We'll do that at the end. Okay? I'll show you how to do that. Let's finish off here. X-intercepts. If you take a look, x-intercepts, remember, is when y equals 0. And in a fraction, y equals 0 wherever the numerator equals 0. Which means, where are my x-intercepts? 4 and 2. Yep. We have two x-intercepts. One at 4, one at 2. And the last piece of information before we take a look at the graph and the cross point. Y-intercept is when x equals 0, except in this problem, x can't equal 0, which means there are no y-intercepts. Okay? That's one of the values that x cannot equal. Therefore, you do not have a y-intercept. Okay? All right, let's put it together, and then we'll actually talk about the graphing part of things. Y-intercept, -1/2. No hole in the graph. X equals 0. You've got a vertical asymptote. X equals 3. Got another vertical asymptote. And then a couple of x-intercepts. One of them is at 2. The other one is at 4. All right, so there is the information that we do have. Now, you should be able to tell me where part of the graph is, based on what we currently have. And I'm going to kind of break this down into parts. We've got the right side, okay, to the right of the asymptote, between the two asymptotes, and then to the left. You've got three different areas. So I know I have either a graph up here or down here. Which one is it? Above or below? Okay, it's above. Because that point right there, that point is above the horizontal asymptote. That tells you the graph is above the horizontal asymptote. So if we put that in, here is your first part of the graph. We can shade that in. I'm actually going to skip to the other end of the graph next because we said we have to look for a cross point in the middle. I want to leave that to the end. The issue with the other side of the graph, I know there's something either above or below the asymptote, but I don't have any points to guide me. What do you think we should do? Yeah, find one. Just pick one. And what you're looking for is, so let's say I took like -1 and I plugged it into the original equation. Doesn't matter if it's original or factored form. Doesn't matter. But let's say I plug in -1 and I see what we get. What I'm trying to decide or what I'm trying to determine is the answer above -1/2 or below -1/2. If it's above, then that's where the graph is. If it's below, then that's where the graph is at. Okay? So let's say we plug in -1. What do we get for an answer? Is -1. What do we get? Let's see. I'm going to save you some time. I'm going to cheat. It's below. Good. Okay. So whatever the answer is, you get an answer that is less than -1/2. Okay? Which means the next part of the graph is down here. Okay, there's the next part of the graph. And now the only thing left is to take a look in the middle and try to determine what's happening there. Is there a cross point? And again, as you saw the answer key, you saw that there was. I will tell you the algebra in general at the beginning is going to look kind of scary, like it's super complicated, but it turns out every time that it's not all that bad. Okay? Here's what I mean by that. Here's how you find a cross point. We are trying to determine if there is a value of x that equals negative 1/2? Is there any value of x that equals negative 1/2? Because if there is, then that is a point on the horizontal asymptote. So what do? Well, if y equals negative 1/2, take the original equation and set it equal to negative 1/2. This is the part where it's going to look scary. Okay? Let's do it. If we take the original, x squared minus 6x plus 8 over negative 2x squared plus 6x, and I set it equal to a negative 1/2. I'm always setting it equal to wherever the horizontal asymptote is located. Because really what this is saying, is there a value of x that equals negative 1/2? If there is, then that's where it crosses the asymptote. If there isn't, then there isn't one. Okay? Now, when you look at this, here's how you then can solve this. Anybody tell me? How do you solve this equation? Cross multiply. Yep. So if we go through, I can take this negative 1 and multiply it by that negative 2x squared plus 6x. So if I do that, I get 2x squared minus 6x. And remember, when you cross multiply, one diagonal will always equal the other. Okay? So there's what I just did. I multiplied those together. Negative 1 times that expression. Now I'm going to go the other direction. 2 times that quadratic. Which means if I multiply all that stuff by 2, we get 2x squared minus 12x plus 16. Now I can solve it. We cross multiply to get a little simpler equation, and now we start solving. Now we start moving stuff around. Let's start with the x squareds. What happens? Those go away. Yep, those are gone. Which means now we can put the x's together. I'm going to take the negative 12x and I'm going to add it over to the other side, which means we will get a positive 6x on this side, equal to, there's 16 still left on the other side. Divide the 6 over, and if we reduce the fraction, you end up with x equals 8/3. Which means that is where you have a cross point. Okay? If you get an answer for x equals whatever, that is the point where the graph is crossing the horizontal asymptote. So if I now go back to the actual graph, 8/3 is 2 2/3. Well, if I just go on the horizontal asymptote to approximately 2 2/3, that means there is a point about right there. That's how you find a cross point. That is how you find a cross point. No, we're going to graph it yet. Yeah, I'm not quite done yet, but we'll graph it. So really, there's two main things with cross points. First one is to identify when do I have to actually check, and that's when there's two vertical asymptotes. And then the second part is, well, then how do I check? And it's the idea, take the equation and set it equal to the horizontal asymptote and see what you get. Okay, we'll do another one in a second. Last question then. Does the graph, is the S-shaped curve a decreasing S-shaped curve or an increasing S-shaped curve? Based on what you see, decreasing. Because the points, as you're working your way through, are decreasing as you work left to right. Okay? The green point is below the red point. Okay? So you know that the graph has to go something like that. So you're using the points that you have to kind of guide you a little bit. After going through one, kind of makes sense. Okay? You probably don't have it quite down, after one problem, but the goal after the first one is to get the idea at least. Okay? So there's what number 6 looks like. Here's what I want you to do then. Let's go to your notes, because I do want to do one more problem together, just to kind of drive it home and go through it again, make sure we're understanding. And then I'll give you a chance to, like I said, practice and see what you come up with. So let me give you this. Here is your other problem that we'll take a look at. And same thing, we'll kind of run through the process. We'll run through everything. So let's start at the same spot we always do. Horizontal asymptote. Top heavy, bottom heavy, tie. Tie, which means y equals, this is 1/4. That is where you have a horizontal asymptote. And again, that's coming from your highest degree terms. Okay? I'm going to skip the cross point for now. I'll come back later. Okay, I'm going to do that at the end again, just because that's the main focus. Hole in the graph. In order to do any of the hole's vertical asymptotes, we need to factor. So let's factor this. We have x minus 4 and x minus 1. And then in the denominator, factor out a 4x, greatest common factor. We'll be left with x minus 3, which means x cannot equal, turns out, it's the exact same values as problem number 6 that we just did on the assignment. 0 and 3. There's the discontinuities. Are either of them holes in the graph? No. There are no factors that cancel, which means there's no hole in the graph. We can go back to that, put down none, which means what is happening at 0 and 3? They are both vertical asymptotes. X equals 0 and x equals 3. Which right there is your signal. Right at this moment is the signal. I need to check for cross points on this problem because I have two vertical asymptotes. Okay, so that's kind of the guide that'll tell you when you have to do that. But let's finish off the x-intercepts, y-intercepts, and then we'll get back to that. Remember again, x-intercept is when y equals 0, which is when the numerator equals 0. Which is when? What is it? 4 and 1. In this case, you have two x-intercepts again. 4 and 1. And once again, very similar to the homework problem, y-intercept is when x equals 0, except x can't equal 0. So there isn't one. Okay? None. All right, and then the last part. Let's actually find the cross point if there is one. Which, let's see where you're at on this. Let me kind of check in here quick. In order to find the cross point, what do I have to do? Set the equation equal to the horizontal asymptote. And see, do I get a value of x that does equal a 4? So again, I'll do it down below. X squared minus 5x plus 4 over 4x squared minus 12x equal to 1/4, your horizontal asymptote. And same thing again, cross multiply. Quick heads up, by the way, just a quick note. Both of the ones we just had were already in fraction form. What would you do if it was y equals 2? Yeah, put it as 2 over 1, and then you can still do the same thing. Okay? So just, even if it's 0, y equals 0, put it as 0 over 1, and then you can do the same thing. Okay? So now, let's cross multiply. When I take 1 times the denominator, we get the denominator, 4x squared minus 12x, equal to the other diagonal, 4 times the numerator, which would be 4x squared minus 20x plus 16. And once again, now we solve. What happens to the squareds? Cancel out again, okay, which is kind of nice. Those go away. I'm going to add the 20x to the other side, giving me 8x equal to 16, which means x equals 2 is where the graph crosses the horizontal asymptote. Okay. So we do have a cross point. Now, quick heads up, because multiple other classes earlier today had asked, well, what does it look like? That's how we find it normally. What does it look like if you don't have a cross point? What would happen? Don't write this down. Just pay attention, okay? Because I want you just to see what would happen. If you take a look, let's say I changed this to this. What happens? You get those cancel. You end up with 0 equal to 16. If all of the x's cancel out, that means there is no x. That means that would equal that, which means there is no cross point then. Okay? So if your x's completely cancel out, and you get something that ends up looking kind of like the 0 equal to 16, then in that case, that's when you would not have a cross point. Okay? All right, let's put it together. Let's graph it all. Let's put everything we have. Cross point at x equals 2. All right, horizontal asymptote, y equals 1/4. We'll approximate where that is. Vertical asymptote at x equals 0. And x equals 3. Cross point we said is at 2. Remember what a cross point is? That's where it crosses the horizontal asymptote. So at x equals 2, I know there is a point right here on that horizontal asymptote. And then a couple more x-intercepts. One of them is at 1. The other one is at 4. All right, and now you should be able to tell me a couple of things for the graph without having to do anything else. First question, if I come all the way over here to the right, above or below? Below, because you have a point down here that tells you that there's got to be a curve down there. So we can go ahead and we can sketch that curve in. There's part of the graph. This time I'm actually going to go to the middle next because we have enough points that we already know. S-shaped curve, it does go through. Increasing or decreasing? This one is going to be increasing based on the points that you have. Yeah. Based on the points that you have, you know that this is an increasing kind of S-shaped curve. And the last thing I need to check, above or below, how do I check? You got to insert a point. Just check a point. And you're trying to determine, is that value, when you plug it in, more than 1/4 or less than 1/4? That's what you're looking for when you test that point out. Okay? What's the answer, by the way? Anybody do it? Above. Above? Okay. So you end up getting an answer that is above. When you plug in, could be anything. Could be -1, -5, -10. And in this case, we get an answer that is above. So there's the last part of the graph. How we doing? Okay? Yes. Not too bad? Like I said, anytime you have two vertical asymptotes, you need to check for a cross point. And that's how you, like I said, what we talked about today is how you do it. All right, with the rest of the time then, I told you to have about 20, 25 minutes. It's exactly what you have. Job number 1, if you did not get the assignment done yet, worksheet number 1 that's due today, make sure you get that done, get that turned in. And then I will give you the assignment for today, or the assignment from today. And you've got the rest of the time to work, ask questions, kind of go from there.